All right, the activity of a sample with a half-life of 23.5 minutes, this is the one that, we got to use right, is initially a lot. What will it be in 6 hours? There we go, right? So what we're going to do is we're going to use this, right? We're going to go n is n naught. Now I know this is strictly the number of nuclei, but we can decay activity as well. So I'm going to stick this as the initial activity, right? E to the minus lambda n, or I'm sorry, e to the minus lambda t, right? Now this lambda here has got to be, I don't know what to do here. What's the most simple thing? I guess I'll just do lambda. Let's do everything in seconds just for kicks, right? Okay, so to find lambda, ultimately, I just know that lambda is just ln2 over the half-life, right? We used to have this formula. We don't now, so we either need to memorize. I'll show you in a second how to get it without this, right? So lambda is ln2, and then I'm going to do everything in seconds. So let's go 23.5 minutes times 60 seconds, right? All right, here we go. ln2 divided by parentheses 23.5 times 60. And I've got 4.9159 times 10 to the minus fourth. And this is per second probability, right? Because this is seconds. The probability is a pure number, so all right. Now let's suppose you don't remember this, right? Just remember that half-life is 1/2 n naught is n naught e to the minus lambda t, right? So it's the time. It's the time that it takes to get to half, right? And of course, we'll end up with 2 is e to the lambda t 1/2. The minus sign went away when I made this. Instead of 1/2, I made it 2, right? And then obviously I can ln both sides is equal to lambda times t 1/2. Right, and now you're all set, right? You can just toss the numbers in there. But anyway, so now we've got this. If you ever need to make that formula, this is the thing you do. You just make it half the original amount, right? All right, so now we're set. Now we can just plug into this guy, right? The amount of activity is the original activity, 3.412 times 10 to the 6th, right, times e to the minus lambda, and this is lambda, so minus 4.9159 e minus 4, right, times t, 6 hours. Oh, good golly. 6 times 3600. Now, the fact that that's per second tells me I've got to put in a time here that's seconds, right? Okay, here we go. So 3.412 E6 times e to the, okay, so opposite of the lambda I just got, times 6 times 3600. All right. Now, if your calculator does not do the exponent like this fancy TI-84 I'm using, you better put this whole thing, e to the whatever, better put that all in parentheses. All right, I'm getting 83.46. This is counts per second, or becquerels, right? And so 83.46 becquerels is all that's left after 6 hours. All right, 6 hours is a lot of half-lives, right? All right, good enough. Now, what will it be? Activity of a sample. What will it be in 6 hours? I'm gonna, this is fine. If you understood this, just, stop watching the video now. Let me show you how I really would solve this. Okay, n is n naught times 2 raised to the minus whatever the time is divided by half-lives, right? Or you can write it this way, right? N is n naught divided by 2 raised to the whatever the time is over the half-lives, right? In other words, you're dividing by the number of half-lives, and this works absolutely, right? So n is 3.412 e to the 6th, right, times 2 to the minus, and then our time is 6 hours, right? So I'm going to go 6 times 60 divided by 23.5, right? Notice that this is minutes, and that's minutes, and so that's good, right? And then we should be good. So let's try that. 3.412 E6 times 2 raised to the opposite of 6 times 60 divided by 23.5. And then, if you do this, you end up not having to deal with the finding out what lambda is, right? There you go. And this works all the time. This was becquerels. So this is also a becquerel, which is a count per second. That's a becquerel. All right. That's a becquerel. That's a becquerel. And your mom was a becquerel. All right, good enough.